All right, today we're going to dive into something really cool, a classic problem in programming, how to calculate the famous Fibonacci number.
So let me ask you, what do you think is the world's most famous number sequence? I'll give you a little hint. You see this pattern literally everywhere. I'm talking from the petals on a flower all the way to the spirals of a galaxy. And it all comes from one super simple rule. Yep, you guessed it, we're talking about the Fibonacci sequence.
So let's get into it. What is this sequence really? Well, at its core, it's just a simple rule, but, and this is the cool part, it has these surprisingly deep implications that pop up all over the place, in math, in nature, you name it.
And here's that rule I was talking about. It's so simple. Each number is just the sum of the two numbers that came right before it. That's it. Now, the whole thing gets started with two seed numbers, 0 and 1. So let's actually build this thing out step by step.
Okay, so it all begins with our two seeds. The very first one, f of 0, is just 0.
And the second seed, f of 1, is 1. Easy enough, right? Now from this point on, that simple rule we talked about takes over. So to get our next number, f of 2, what do? We just add the last two together. So 0 plus 1 gives us 1.
And for f of 3, same deal. It's 1 plus 1, which of course is 2. You can already start to see the pattern taking shape.
Next up, f of 4. We take the previous two numbers, 2 and 1, add them up, and we get 3.
And one more for f of 5, it's 3 plus 2, which lands us right at 5. So there you have it, the sequence starts to build. 0, 1, 1, 2, 3, 5, and it just keeps going, forever. So the big question for us is, okay, that's cool, but how do we actually get a computer to calculate this?
All right, so our first solution is probably the one you'd think of first. It's the most intuitive. Let's call it climbing the staircase, because it's all about getting to the top by taking one steady, reliable step at a time.
So here's how the logic works. First, you set up two variables. Let's call them a and b, and you start them off as 0 and 1. Then you just loop n times, n being the number you're trying to find. And inside that loop, you do this clever little swap where you calculate the next number and shuffle your variables to keep moving up the chain.
And this is really the heart of the loop. On every single step, the value that was in b slides over into a, and a brand new value, the sum of the old a and b, becomes the new b. And what's really slick is that in a language like Python, you can do this whole song and dance in just one super elegant line of code. Okay, so this brings us to performance. How fast is it? Well, this method has what's called linear time complexity, or big O of n. Now that's just a fancy way of saying that the time it takes grows in a straight line with the input size. So you need the 10th number, it's going to take about 10 steps. The 100th number, about 100 steps. It's super reliable, totally predictable. But is it always the fastest way?
Well, that brings us to solution number 2, the matrix leap. Or let's stick with our building analogy and call it taking the elevator. Because let's be real, when you're going to the 100th floor of a skyscraper, you're not taking the stairs.
I mean, think about it. What if we need to calculate f of 1 million? Yeah, 1 million steps on our staircase is going to take a while. The simple loop just becomes totally impractical for these huge numbers. We need a way to, leap forward instead of taking all those tiny little steps.
And that leap? It comes from a really clever trick, using a bit of linear algebra. It turns out you can actually encode that add the previous two numbers rule into a special little matrix. And every time you apply this matrix, it's the exact same thing as taking one step forward in the sequence.
And here it is, this simple 2x2 matrix. It basically says the next number is 1 times the previous one plus 1 times the one before that. It's our rule, just encoded in math. So multiplying by this matrix once is the same as taking one step. So what's the shortcut here? What's the elevator? This is the big aha moment. To take n steps, you don't have to multiply by that matrix n separate times. No way! You can just raise the matrix to the nth power. And because there are super fast algorithms for doing that, we can calculate it in what's called logarithmic time, or O of log n. It is literally the difference between pressing the elevator button once and running up 1 million flights of stairs.
So there we have it. We've got two really powerful tools in our belt, the staircase and the elevator. And this brings us to a classic dilemma that every programmer faces.
Let's just put it all side by side so it's super clear. You've got the simple loop, that's your O of n, linear time. It's easy to write, easy to understand.
Then you have the matrix leap. That's O of log n, logarithmic time. It's definitely more complex to set up, but it's wildly exponentially faster when you're dealing with massive numbers. And really, that's the main takeaway here. There isn't one single best answer. The right choice completely depends on the problem you're actually trying to solve. If you're dealing with small numbers, hey, the simple loop is perfect. It's clean, it's easy. But if you're working with enormous numbers, the matrix method is pretty much the only game in town.
So this kind of leaves us with a final thought, right? In our world, we're so often obsessed with finding the absolute fastest, most optimized solution for everything. But we can forget that sometimes simplicity and just being able to read and understand the code, that has a huge value all on its own. Knowing when that straightforward, good enough solution is actually the best solution for the job, well, that's what separates a good developer from a great one. So what do you think?